Hey there! Let's dive right into the fascinating world of Python tuples and how to sum their elements. If you are an IT fresher, or even just trying to refresh your memory, you'll find this topic both useful and engaging. So, grab a cup of coffee, and let's explore together. Tuples in Python are like those small, hard containers that hold all your goodies secure. Imagine putting several numbers or elements into one of those, and then looking for a way to add them all up. That's what we are here to discuss today. First, a quick way to understand tuples is to see them as fixed-size boxes of data. This makes them different from lists because once you've populated your tuple, it's set in stone, no changing. You might think, but why not always use lists? Well, lists are flexible, allowing modifications on the fly, but they can be more processing heavy for certain tasks. Tuples, on the other hand, can sometimes offer performance optimizations, which is super cool for performance-sensitive code. Consider you've got your tuple of integers, something like this: Python tup is equal to sum the elements. Python has its ways, both straightforward and a touch more imaginative. The traditional and fastest approach is using the built-in sum function. Python total is equal to sum print hash output 15. Simple, right? It's like having Python count the fruits in your basket automatically. But hey, Python isn't just about using what's available. It's about doing things well, which means sometimes getting creative, especially when working with loops and tuples. So, imagine having a list of tuples, and we wanted to sum up the elements of each tuple. We'd summon loop-based wizards up. Python list _of_ tuples is equal to total _of_ each is equal to print hash output. Now imagine you've heard about generators and their lazy loading prowess. It's like Python's way of saving its breath. In Python, a generator isn't about making or breaking a physical machine, but it's a function that returns an iterable set of data, like a magic mirror that reflects values on demand. You could create a generator function to sum tuples element-wise with this on-the-fly enchantment: Python definite tuple _element _wise _sum, return tuple for I in zip, print, hash output. But you are curious, aren't you? Performance, the silent guardian of your code's efficiency, often dictates the right choice. While the comprehension approach gives us clarity and readability, for vast data or tight loops, the internal magic that lies in itertools.izip and Python's bytecode interpretation can offer glimpses of speed improvements, like a well-trained cheetah sprinting over your data. It's like comparing a cheetah's speed to that of a tortoise. Of course, if performance is your primary concern, especially when it comes to multiplying or extending the tuples, using numpy arrays and vectorized operations often beats the traditional Python loop. Their optimized C implementations handle these tasks like seasoned professionals, churning through gigabytes of data with unrivaled speed. But hey, Python's got a trick or two up its sleeve: the map function. The older and well-versed maestros of the Pythonic realm, like map and filter, can be reincarnated for summing tuples with its touch of functional magic. Python sum _using _map is equal to map print. While map can be a powerful tool, here's a little cheeky fact: its overhead can sometimes turn performance into a mundane chore, so it tends to find its fame in scenarios where clarity of code and legibility are championed over raw speed. Speaking of legibility and code purity, list comprehensions often find a home in Pythonic code. Though lists are mutable and a touch cheaper, Python's C-optimized loops will outshine these beauty routines in raw, brute force processing power scenarios. Now, as promised, if you are feeling hungry for more Python treasure or needing help navigating this Pythonic landscape, visit me at neeraj.qzz.io. Right here, Python, remember, whether you are using the sum built-in wizard, diving into the depths of looping spells or considering the allure of NumPy's vectorized charm, the right choice hinges on your specific quest at hand. Performance isn't the sole victory parameter, clarity of code, personal preference, and the spirit of Pythonic code often guide the way. So, with that, consider this your Pythonic treasure chest of knowledge. Take these insights, explore the realm of summing elements in tuples to your heart's content, and may your coding journey be both efficient and delightful. Till we meet again, fellow Python enthusiasts, subscribe to TechLab and keep riding the waves of Python programming excellence together.